Hello students, welcome back to my channel, and today we'll start with chapter 3 metals and non-metals of class 10 science. We'll start to solve the textbook exercise questions given on page 56. So let's start. So look into the questions given on page 56, but before we solve it, let us recall what was elements and compounds. So an element is a substance that cannot be decomposed into simple substances by any physical or simple chemical method. So an element is composed of atoms of only one kind. Elements can be classified into two major groups, that is metals like gold, silver, and non-metals like carbon, sulfur, etc. Now let's see what is compound. A compound is a substance made from two or more different elements that have been chemically joined. For example, water, which is made from the elements hydrogen and oxygen, and table salt, that is sodium chloride, which is made from the elements sodium and chloride. So the first question here is, which of the following pairs will give displacement reactions? So sodium chloride solution and copper metal. Number B, magnesium chloride solution and aluminum metal. Number C, ferrous sulfate solution and silver metal. And number D, silver nitrate solution and copper metal. To solve question like this, you must remember that in case of metal, displacement reaction is related to the reactivity of the metal. So in the lesson in page number 45, it is mentioned reactive metals can displace less reactive metals from their compound in solution or molten form. So you should know which are the reactive metals, which are the least reactive metals, and for that this table will help you to find out. So the most reactive metals, relatively less reactive metals, they are arranged in a sequence. So you should know this table very well to answer such questions. So the answer to question number 1 is option D, that is silver nitrate solution and copper metal will give displacement reaction, because copper is comparatively more reactive than silver, so it will displace silver. But in the other cases, in the other options, like in A, copper metal is less reactive than sodium, so there will be no displacement reaction. Similarly, number B, aluminum is less reactive than magnesium, and also silver is less reactive than iron, so there will be no displacement reaction. So the answer is option D, silver nitrate solution and copper metal will give displacement reaction. Question number 2. Which of the following method is suitable for preventing an iron frying pan from rusting? Option A, applying grease. Option B, applying paint. Option C, applying a coating of zinc. And option D, all of the above. So the right answer is option C, applying a coating of zinc. No doubt applying grease and paint also prevent rusting, but this cannot be applied to an iron frying pan because it will be repeatedly heated and washed, and so we cannot apply grease or paint. So the correct option is option C, applying a coating of zinc. Question number 3. An element reacts with oxygen to give a compound with a high melting point. The compound is also soluble in water. The element is likely to be calcium, carbon, silicon, iron. Now option A is calcium. Calcium reacts with oxygen to give a compound called calcium oxide, which is also known as lime or quicklime. It dissolves in water, and since it is a metal oxide, it has a high melting point. So option A fulfills all the conditions mentioned in the question. So our answer is calcium. Now let us analyze why not the other options. So number B is carbon. Carbon, when it reacts with oxygen, it gives carbon dioxide, and carbon dioxide, it dissolves in water, but since it is a gas, it has a low melting point. Then number C is silicon. Silicon, when reacts with oxygen, it gives silicon dioxide. It is a solid, no doubt it has high melting point, but it is insoluble in water. And number D, iron. Iron, when it reacts with oxygen with presence of moisture, it forms rust or iron oxide or ferric oxide, and it has high melting point since it is a metal oxide, but it is insoluble in water. Now here I want to mention that carbon, when it reacts with oxygen, it also forms carbon monoxide in certain situation when there is lack of oxygen, that is during burning of fuels and other things. Question number 4, food canes are coated with tin and not with zinc because zinc is costlier than tin. Zinc has a higher melting point than tin. Zinc is more reactive than tin, or zinc is less reactive than tin. So here the answer is option C. Zinc is more reactive than tin, so we do not use the coating of zinc in food cane to avoid reaction with the food. Let's see question number 5. You are given a hammer, a battery, a bulb, wire and a switch. Number A, how could you use them to distinguish between samples of metals and non-metals? Number B, assess the usefulness of this test in distinguishing between metals and non-metals. So you are given some materials, and how will you use those materials to distinguish between metals and the non-metals samples given to you? Second part of the question is assess the usefulness of this test. Assess means to judge or give your opinion how useful was this test. So I have given the answer to question number 5 here. So A, using a hammer we can test the malleability of the samples. If the sample can be beaten into thin sheet, then it is a metal, otherwise it is a non-metal. Similarly, we can use the battery, bulb, wire and switch to set up a circuit with the sample. If the sample conducts electricity, then it is a metal, otherwise it is a non-metal. Number B, the above tests are useful in distinguishing between metals and non-metals, as these tests are based on the physical properties. No chemical reactions are involved in this test. Next is question number 6. What are amphoteric oxides? Give 2 examples of amphoteric oxides. Now here you pay attention to the word ampho. Ampho means having dual nature, double nature. Like in biology I've studied amphibians. So those are animals which can live both on land and in water. Similarly, here the word amphoteric oxide, it means those oxides which have double nature. Okay, so let's find out what are amphoteric oxide. I have given the answer here. So the answer to question number 6. Some metal oxides show both acidic as well as basic behavior. Such metal oxides react with both acid as well as base to produce salts and water and are known as amphoteric oxides. 2 examples of amphoteric oxides are aluminum oxide Al2O3 and zinc oxide ZnO. Now if the question carries more marks or you are asked to show the reaction, you can include these reactions as well. So let's see the reaction, that is aluminum oxide reacts with hydrochloric acid or aluminum oxide reacts with sodium hydroxide. So Al2O3 plus 6HCl, it gives 2AlCl3 plus 3H2O, that is sodium chloride plus water. Then again, when aluminum oxide Al2O3, it reacts with 2NaOH, that is sodium hydroxide, it gives sodium aluminate, that is 2NaAlO2 plus H2O. Again, when zinc oxide reacts with hydrochloric acid, that is ZnO plus 2HCl, it gives ZnCl2, zinc chloride plus water. Then again, when zinc oxide reacts with sodium hydroxide, that is ZnO plus 2NaOH, it gives Na2ZnO2 plus H2O, that is sodium zincate plus water. Question number 7. Name 2 metals which will displace hydrogen from dilute acids and 2 metals which will not. So let's see the answer to question number 7. That is, metals which are more reactive will displace hydrogen from dilute acid. For example, iron and zinc. Fe plus 2Cl, Fe Cl2 plus H2. Then Zn plus 2HCl will give ZnCl2 plus H2. Metals which are less reactive than hydrogen do not displace hydrogen from dilute acid. For example, copper and silver. Copper plus HCl, there will be no reaction. Then silver plus HCl, there will be no reaction. So dear students, thank you so much for watching, and the rest of the questions I will give you in the next video. So don't forget to subscribe the channel and hit the bell icon. Thank you so much once again.